Hello and welcome to my video where I'm going to talk about potential energy. So here we have, first of all, the basic formula for energy, and that is, for potential energy, and this is specifically talking about gravitational potential energy, okay? And this is where mass is m, gravity 9.81, I'll just write that down, meters per second is the g, and the h is the height. So mass and height. All right, so this is our function here, or our equation. I'm doing a lot of math as well right now. Our equation. So the other basic one is just FD, where you have force times by the distance, and we'd use this one more likely for a spring. Okay, so this would be a spring energy, spring potential. Okay, whereas this is gravitational potential. All right, so if you can imagine in these cases here, if the force is 0, right, if you multiply any number by 0, then the energy is 0. All right, if the mass is 0, then energy is 0, and if height is 0, then the energy is also 0. Okay, so it doesn't matter on any of these things. If any of them are 0, energy equals 0. So what is potential energy? Well, potential energy is basically anything where it's a stored energy. Normally, in this course, we talk about gravitational or elastic potential. Spring potential is another way of saying elastic. Okay, so we normally talk about these two, but realistically, potential energy could be anything stored, like chemical energy, thermal energy can be stored potentially. So potential energy just means what could potentially happen, but usually we say gravitational potential. And normally we use the first equation, which I will just underline in red. Okay, so let's use that equation now and see what we get. So maybe I'll just rewrite out that equation right here above so that we don't forget. So the energy potential is mass times gravity times height. Sorry about that noise there. Mass times gravity times height. So Mr. Draeger lifts some weights because obviously he's super jacked. And actually some of my things are going to be kind of wonky. I might have to change some numbers here now that I'm thinking about it. Yeah, they're going to be wonky. Okay, I might change some of these numbers around down here, but should be all right. Okay, anyways, Mr. Draeger is super jacked, so he's bench pressing 125 kilograms, which is absolutely nuts. There's no way I could actually do that. But anyways, and I lift the weight 72 centimeters up. In a perfect system, how much energy did Mr. Draeger use? Well, we just plug it into our formula. So this is the normal way of writing down a physics problem. You write down the formula, then you write down all the parts you know, and you rearrange and solve. And in this case, it's pretty straightforward.
Lee Martin, if you're still in the school, could you please come to the front office? Thank you.
Sorry about that. Mass is 125 kilograms. Gravity is 9.81 meters per second squared. And the height is 72 centimeters. Now this is a little bit of a trick I did on purpose. We have to change it to meters. Okay? Because whenever we're using calculations to go from one unit to the other, to another, like in newtons or joules, and we talk about meters, we have to have meters, we have to have seconds, we have to have kilograms. These are SI units. We need to be in those units for it to calculate out properly. Okay, so if we do all that, what are we going to get? I'm just going to, oh, maybe I can plug it in my computer calculator here. So where is it? 125 times 9.81 times 0.72. Enter. So that tells us that the answer is, what did it say? 882.9. And that would be joules. Okay, now that's great. However, it's not quite done yet because we have 2 and we have 3 sig digs, so 2 is a smaller amount. So we actually need to write 8.8 times 10 to the 2 joules. And that is our actual final answer. All right, so here let's take a look at this question. We have a crane lifts some heavy steel beams, 1,500 kilograms up to the 3rd floor of a building, 8 meters up. How much potential energy did the beams gain? So same process. Okay, again, pause the video, then try out the question. Okay, so pause the video right now, and then go ahead and try it. All right, so hopefully you were able to try this question out. If you haven't, pause the video and try it out right now. But basically, we're going to put the mass in, then we're going to put the gravity in. So it's just like the last question. And you're going to put the meters in and find your answer. So that is, that is 1,500 times by 9.81 times by 8.00, or just 8. And so we get 117720. 117720. Okay, so that is 117,720 joules, which is nice, but we need to have sig digs. Here we have 3, here we have 4, so we're going to go 3 sig digs. 1.18 times 10 to the 1, 2, 3, 4, 5 joules, and that is our final answer. Okay, taking a look at the next question here, I'm hoping that, roughly speaking, we're going to be close enough to an answer. Yeah, it'll be close enough. It won't be exactly right. Let's go with, let's change this to 4. Let's change this to a 6. I had more exact answers, but we'll go with this and see how it goes. All right, so how much does the elevator weigh? So if we have this many joules, maybe I'll highlight it. We have this many joules, and we go up this many meters. How much does the elevator weigh? Oh, okay, so now we're looking for a different part of our question. So we start by writing the formula, but then we need to actually rearrange it to get something useful. We are looking for the weight. So we want to rearrange it by dividing by the G and the H. And if we do it to one side, we do it to the other. That lets us move over the G and the H. So now we have mass equals energy over gravity times height. So now what we can do is we can fill in our energy is 44,000 joules divided by gravity 9.81 meters per second squared times by height, which is 3 meters. Okay, and then we plug that into our calculator. So 44123 divided by bracket, this is important, 9.81 times 3 bracket. Otherwise, your calculator is going to give you an error. You have to remember those brackets because both are being divided. Okay, press equals, and we get a value. So it's not it's not what I originally had in mind, but it's close enough. Okay, so this many kilograms, because we're looking for the weight, the mass. Okay, so let's look at the sig digs now. We have 3, and we have, what is that, 5, so we need 3 sig digs. So 1.50, it'll round up, times 10 to the 3 kilograms, and that is our final answer. Okay, looking at the last one here, same sort of deal, except that we are looking for a different answer here. So first of all, if it takes this much with one passenger, what we're going to do is we're just going to subtract it from the original amount. So what's the difference between these two? Maybe I can highlight it so you can see what I'm talking about. This number and this number, what's the difference between them? And so what we need to do is, let's do green, is subtract those. So 46,000 minus 44,000, and so we get 2,000. Okay, so that is our answer for the weight, or the amount of joules it takes extra for the one passenger. So it's still lifting the elevator, but now it's just lifting that as well. So actually we can get rid of this, and we can just use the formula that we found last time, which is the mass equals energy over gravity times height, which means we're going to have 2,000 joules, and then just the same bottom part, 9.81 times by 3. And so if we plug that one in, we'll go 2,000 divided by 9.81, times by 3, bracket, enter. And the person weighs 67.95, I think is what it said. 96. Okay. And so let's just compare what we have in terms of sig digs. So we have 3 from the 3 meters, and we have 4 from the joules. So we need to end up with 3 sig digs. So we can just put it as 68.0 kilograms. And you have to have the 0.0, otherwise your sig digs are wrong. All right, I hope this video helps you understand potential energy and how to calculate it a little bit better. Good luck, everyone.